Today we are going to understand the law of conservation of mechanical energy in case of a freely falling body. It means when any body is under free fall, that time we have to understand the amount of mechanical energy. And I hope you know the mechanical energy. It's a sum of kinetic energy and the potential energy of any object. It is called total mechanical energy. It means the ME, short form ME, mechanical energy, is equal to the sum of PE, potential energy, plus kinetic energy, KE. That we have to prove that every point during the free fall will be equal or the same. So to understand these derivation, we need to understand first the image. Okay, that means the figure what we are going to make here. So first of all, we need to consider one object here. This is the point A for us. This will be at height h. That means the total height of this object from the ground, this is our ground surface, okay, is h. Okay, now it will about to fall to the ground, so the ground will be our point B. Okay, so this is a point A, this is a point B. Point A, we are just holding the body which is having mass m something. Okay, we can consider the mass m, and this body or this object is about to fall on the ground which is on B. Now during the fall we will consider one point in between somewhere AB, the point C, where we actually consider this point for checking that the mechanical energy of the object is going to same or not. So this is our figure, and in this figure also we get to know that during the free fall from the point A, if the point C we are considering, so due to the falling A to C, suppose that the object has traveled x distance, that means the AC is x. So at point C the remaining height will be h minus x, because the total height was h, and already from A to C the object has traveled x distance, x meter you can say, whatever it's you depend upon your unit. Okay, x unit he has traveled. So the remaining distance will be from C to B. From C to B it will be how much? H minus x. And this C point we are just considered. During the free fall the object is not going to stay at this point C, just because whenever from a certain height the free fall will start, it will directly towards ground, come towards the ground. It will not stand or not stay somewhere in between that. Okay, just because we know that change will only come when we put an external unbalanced force to it. Since we have not put it here, that's why between the A and B, the C point we are just considering, and we will check that at this point the amount of mechanical energy will be the same or not. This is all about the image over there. Okay, I hope the figure is very good, clearly understand to all of you. This figure is actually the backbone of this derivation, so I hope you have cleared it successfully. Now we are approaching towards the point A, point C, and then point B. Just remember one thing, we have to prove. What is the proof here? The law of conservation of mechanical energy. So during the free fall we have to prove the mechanical energy which is equal to the sum of potential and kinetic. Okay, this is called the mechanical energy here. So this is going to be equal in the point A or on the point B as well as point C. These all points the mechanical energy should same. Then we can say that the total mechanical energy of the body throughout the free fall is conserved. So let's see what happened. So we are going to start from the point A. So at point A, okay, at point A what we are actually seeing right now, the object which having mass m, mass is given how much, this is small m, that we are holding on the point A. Actually right now it's not about to fall, okay, sorry, it's not falling, it's about to fall. About to fall means you are just holding at the point A, so that time it is, the object is not doing the motion. That is why at point A the potential energy due to the gravitational potential energy is equal to m into g into h. According to the formula, we know that P equal to mgh. That's why this is the first equation for us. The potential energy at point A, it will be mgh. Now we will find out the kinetic energy here. Since we know at this point A we are just holding the object at the same point, it's not falling, it's just about to fall, okay, so that's why it is not doing the motion. And we know the kinetic energy formula is half mv square. Since it's not falling, okay, so the motion will be not there, that means the u will be 0 and also v will be 0, okay. So for that we can say that total kinetic energy is also 0 here. This is our second equation. Now we know what we have to prove, the mechanical energy here. Let's find out the mechanical energy at this point A. So at point A the total mechanical energy is equal to potential energy plus kinetic energy. We know now potential energy we got from the point A 1, it's called m into g into h, plus the kinetic energy is 0 for us. The total sum is mgh, okay. So mechanical energy at point A is equal to mgh, we have found out. Now this same value we have to check, we have to prove that at point C and point B is the same or not, okay. So let's move forward to the point B. I hope this point A is clear to all of you. You can pause the video and you can check out that which point is not clear. You can repeat this once again. Now at point C we need to find out the total mechanical energy, but we know that for finding out the mechanical energy we need to know the potential and the kinetic as well. So let's find out the potential energy at this point C. So at point C, as you can see here, at the point C the remaining height is h minus x. This is h minus x. The potential energy due to that same height we are going to find out. So the formula we know that m, g and h dash, okay. H dash, why I'm writing, just because last time we have taken the h, total height h, okay, but the height has changed at point C. Up to point C the total height is now h minus x. So instead of h, okay, h dash, we will put that h minus x. So the P is equal to m into g into h minus x, the remaining height from this point C, okay. I hope I'm clear to all of you. Now you can just multiply this mg towards the h and x both. As a mathematical formula we use it. We can write mgh minus mgx. This is the value of potential energy at point C, okay. This is the equation 1 for us. Now the kinetic energy, we need to find out the kinetic energy at this point, and we know the formula is half mv square. Since the initial velocity was 0, okay, that means u equal to 0 at the point A, and during the travel, that means the free fall from point A to point C, it has covered the distance x distance already has covered. So u equal to 0 here. So we can interchange the v square by the formula third equation, v square equal to u square plus 2g into x. That means the height from where it's traveling, okay, from the point A it's come toward the C, it's x, and u was 0, so we can write that v square equal to 0 plus 2gx, that we can write here. So we can replace the v square by 2gx, because when you add 0 it's nothing going to change. So the ke, kinetic energy at that point, at half m into v square, we have interchanged by 2gx, and 2 and 2 we can cancel out, and we can write the Ke is equal to 2gx. That is the second equation for us. So we have found out the value of Ke, kinetic energy, at point C. Remember one thing, that the Pe, potential energy, always we find out as per the remaining distance from the ground, okay, and the kinetic energy, obviously we are actually expanding it, okay, to increase the velocity of the object, okay. So the Pe now going to convert, just because you can see the Pe already get less. Previously it was mgh, now the mgx has subtracted from it. It means the value of P is going to downward, and now it will going to increase in the form of kinetic energy, okay. That is how the energy is going to transform. The Ke value we find out 2gx, but finally we need to find out what? The mechanical energy, and that mechanical energy is equal to Pe plus Ke, potential energy plus kinetic energy. That is equal to what? Again we can write from the equation 1 and equation 2 that mgh minus mgx, and the kinetic energy value we have 2gx, okay, no sorry, not 2gx, we can write mgx, just because 2 we can cancel out, and just m we going to multiply here. Sorry for the problem here. It is mgx, okay. So we can write plus mgx, okay. I hope it's clear to everyone. Now mgx and mgx we can cancel out, and what we are getting? Me at point C, Me at point C is equal to mgh. Previously at point A we got the value of Me, the mechanical energy, the total mechanical energy was mgh, and now on point C also we get mgh. It means till point C the conservation of mechanical energy is true right now. So I hope this point is clear to all of you. At point C how we get the value mgh once again. Next and the last one is at point B, that means at a surface, when the object will reach the surface B, that time what will be the mechanical energy, okay. You can pause the video and you can review over the whole procedure, that how we are finding out the mechanical energy at point C. So now we are going to find out the total mechanical energy at point B. Since at A point and C point we got the value of total mechanical energy is mgh. Now this is the last point at point B, how we are going to prove that the total mechanical energy is still mgh. So let's find out first the potential energy at this point B, okay, that we actually going to find out first, because for mechanical energy first we need to calculate the value of the potential as well as the kinetic. So the potential energy at this point P, the value is mgh dash, okay, because h has changed, so the formula is mgh. But we know that at point B, when the object will touch down the surface here, so the remaining distance from the object towards the B will be 0, just because it's already getting to touch, okay. That is why the h will be 0 here. We can write 0, and the total value of potential energy will be 0 here. This is the first equation for us. I hope how you get that. You getting that? Okay. So how we can get in that? That's like when the object is coming towards the ground and it's touching down the surface, that is the point B. It means the remaining distance between the object and the surface is 0 now. That is why the height will be 0 here, and the potential energy, when we multiply by 0, everything becomes 0. So that's why the mechanical energy at point B is 0 we get. Now next we have to find out the kinetic energy at this point B, and we know the value of kinetic energy as in formula half mv square. So now we have to again interchange the v square by another formula. This is the one and only v square equal to u square plus 2g. Now instead of h or x, what we should put here, just because object is already reached to the point B, okay, and the total height he has covered from the point A towards B is x, okay, h here, total height he has covered. Now we don't have to write that x or h plus h minus x, otherwise you can do that also. If you can write the total distance covered by the object from the point A to B, it will be x plus h minus x. So xs will be cancelled out and remaining height will be h only. It means total height h he has covered. So we can write 2gh here right now. Okay, at this point B I am saying. It's not valid for the point C or A. That time the condition was different. But right now on the point B, the object has covered total distance h from the top. Okay, and the remaining height is 0. That's why the P is 0 for here. But the K is dependent upon the total height covered by us, that is called h. Okay, and U we know already it is 0, initial velocity at the point A, just because at the point A it was on the rest. That's why it will be 0 over there. So the V square will be equal to 0 plus 2gh. So the V square equal to 2gh, that we can write. So we will replace this value with the help of this equation, and we can write that Ke is equal to half. I'm writing with another pen. Okay, the Ke is equal to half m into, instead of V square we replace the value by 2gh. Okay, again we can cancel out 2 and we can write the Ke is equal to mgh. But here this is the second equation only, it is not the end. So what we have to find out, the total mechanical energy at this point C, sorry, point B, because at the ground it is point B. So the ME will be how much? That will be equal to the PE plus KE. Since the PE at this point B already we get what, 0 here. Okay, plus the kinetic energy for the second equation we got how much? It's mgh. Okay, so the total mechanical energy at point C is equal to mgh. So like previous equations we get from the point A, point C and point B, in these all points we get the same value of mechanical energy is C equal to mgh. Okay, in each point A also mgh, C also having mgh and the B also having mgh only. This proves the total mechanical energy of the body throughout the free fall is conserved. I repeat, the total mechanical energy of the body throughout the free fall is conserved, just because at point A, at point C and at point B, that means from A we are going to throw the ball towards the ground, okay, and point B where it will touch down the ground, and at C what we have considered the object to be stay there, okay, considered. So these all points we have the same value of mechanical energy, it is equal to mgh. I hope the whole derivation is very clear to all of you. Okay, thank you all of you, have a nice day. Jai Hind.